Bismillahirrahmanirrahim. In this lecture, we will explain how causation is part of the deep structure of reality and cannot be observed in the surface appearances, which are like the data available to the statistician. It is a standard saying among statisticians that correlation is causation, but nobody really explains why. And the goal of this lecture is to understand how to separate these two concepts clearly. Understanding causation always requires going beyond the data to the real world structures generating the data. We have been discussing an example of monetary policy. So one example in the case of monetary policy is the issue of nominal interest rates, which are what you see in the world, and real interest rates, which are the unseen. And basically the difference between the nominal interest rate is like the market rate, which is suppose the bank is giving you 10% interest rate, but the inflation rate is 5%. So for inflation rate 5% means that $100 today is worth will be worth 105 tomorrow, or $100 today is equivalent to 105 tomorrow. So if you earn 110, you have only made actually $5 and not $10, because 5 of those dollars have been, the purchasing power has been eroded by inflation. So that's why basically the formula is that the real interest rate is nominal interest rate, what you see, minus the inflation. So we're going to construct an extremely simplified example, hypothetical example, where the monetary policy authorities decide that they should set the real interest rate equal to the economic growth rate of a certain economy. This is for the purposes of our example. It's actually considered to be a reasonable rule in some theories of economy, but we don't really care about this. We're just trying to create an example which shows how the deep structure, and this is the deep structure that we're going to explore, that the monetary policies have this goal in mind. What is the goal in the mind of the monetary authorities is not really accessible easily by observation, and certainly won't show in the data. In contrast to the idea that statistics is purely concerned with analysis of numbers, in real statistics we say that we must look at the real world structures, and so we explore a hypothetical, simple, small economy which has only one product which it exports and all of the products are imported. What this means is that the costs of imports are determined in the global market, which is not affected by the local small economy. So basically that means that the prices of the goods are exogenous, and that means that the inflation is determined by the global economy and not under control of the domestic economy. We assume that inflation follows a very simple process. It's determined in one period, and there are a few shocks which occur each period, and these shocks change the inflation rate. These shocks are the shocks to the global prices. The central bank measures this current inflation because it's trying to offset the inflation according to its policy, but it can't accurately measure current inflation for the moment. Let's assume this. So it measures the current inflation with a measurement error. And suppose that it can accurately measure last period's inflation. To take an extreme example, suppose that the central bank knows nothing about the current inflation, it only observes last period's inflation. So even though it would like to address current inflation, the best measure it has of current inflation is last period's inflation. And so what will it do? It will set the nominal interest rate equal to the last period's inflation in order to achieve zero real interest rate. Let's assume that's their goal. They want to keep the real interest rate at zero. That happens to be the monetary policy stance in Pakistan right now. So what will this do? If you set nominal interest equal to last period's inflation, this will set the real interest rate equal to the random shock, the amount by which the current inflation deviates from the last period, because that's not known to the banks, so they don't know how to offset that. So the real interest rate will be equal to the random shock to the prices in the global economy. Now, if we do a data analysis of this economy, we'll come to a number of wrong conclusions. First of all, we will see that there is a strong correlation between last period's inflation, and current nominal interest rate, and we might be tempted to conclude that the last period's inflation causes contemporary nominal interest rate. And this conclusion is actually false. Even though it seems that way on the surface, the reality is that it's not the inflation which is determining nominal interest rates, it's the policymaker's goal. If the policymaker changes his goal, this causality will break down. So what is a stable correlation on the surface is actually held up by a real mechanism which can change. The other conclusion you would come to is that the real interest rate has no effect on the economy because it's determined by global income shocks. Again, this is a false conclusion. This happens to be true because the central bank is not allowing the real interest rate to fluctuate very much. And so this doesn't tell us, this data set will not tell us anything about what happens when the central bank tries to change the interest rate, because it has never done so. Random fluctuations of the interest rate, of the real interest rate, will not give us the information about what will happen when the central bank changes its policy. Doing data analysis of a set like this is useful to introduce a technical concept called screening. And screening is based on looking at and trying to differentiate between different possible causal structures which lead to similar looking correlation patterns. So one of the assumptions which we'll actually dispute is that causation is assumed to go forwards in time. Something happens in the past causes something in the future. Something in the future cannot cause something in the past. This is actually not true, but this is one of the assumptions that is the basis of standard analysis of causality. So if X occurs before Z and X is highly correlated with Z, then X is a potential cause of Z. So now in this case, we have inflation at T-1 occurs before current discount rates and is strongly correlated. So the data suggests that inflation at T-1 is the cause of nominal interest rate at T, even though this is false. If both X and Y are highly correlated, then we'll look at the additional information. So for example, inf at T and inf at T-1, current inflation and past inflation are both highly correlated with the target nominal interest rate. So this is a situation where we have to discriminate between different possible causal structures. One is the causal structure which is called common cause. So if Y and Z are highly correlated, it can be due to the fact that both are caused by the same variable, in which case there is no causal relationship between Y and Z, but a third variable causes both of them, and this creates the correlation. But there are other ways in which both X and Y can be correlated, and one of them is called the moderation. X affects Y, which affects Z. So Y and Z are highly correlated, and X and Y are highly correlated, and also of course X and Z are highly correlated. In this case, we say that Y screens off the effects of X on Z. That's because once you know Y, then you have all the information you need to predict Z, and X no longer matters. If you don't know Y, then X is useful in predicting Z. So in this situation, both X and Y will be highly correlated with Z, but when you have Y, you won't need X anymore. So this is the situation that we have. An alternative is that Z and Y are reversed, and so now Z screens off the effect of X on Y. And so these things, in all such cases, all the three variables are highly correlated, and so to detect the actual structure, you need to check for what one variable does in presence of the other. here in the second diagram, Z screens off the effects of X on Y. So how does this apply to our current situation? Well, in this current situation, past inflation is equal to nominal information, and current inflation will provide no additional information if you look at the data set. Inflation at T will be highly correlated with normal interest, but if you look at this relationship, you will see that inflation of T will not be as accurate as of T minus 1, and the past information will provide additional information. So in the terms of this terminology, you can say that inflation at T minus 1 screens off the effects of inflation at time T on nominal interest rates. So basically you can conclude that inflation in the past is a direct cause of nominal inflation, and current inflation is not, which is actually contrary to what is really going on. So why are the correlation clues false and misleading? Well, basically we are presenting a new theory of causality here, and that is that the action is driven by the goal of the policymaker. The goal is unobservable. So the standard theories of causality work in terms of action leads to effect, but the action leads to observation. We say that that's not an accurate analysis. We say that action is created by the intended effect, not the actual effect. So the standard analysis says that action leads to observed effect, but we think causality lies in the relationship between the action and the goal, and the relationship between the action and the observed effect is actually an accidental byproduct. So here the correlation pattern will show us that inflation in the past is a common cause of current inflation and nominal interest rates. The correlation but suppose that we change the circumstances slightly. Now suppose that accurate statistics for current inflation become available to the central bank, then suddenly the correlation pattern will change, and instead of being a common cause, we will see that inflation in the past causes current inflation, which causes nominal interest rates. So both of these are just created by small changes in surface manifestations. In the original example, the central bank is unable to observe past inflation, and in the current it is able to observe current inflation, and that causes a big change in the causal structure. But the real causal structure, what the central bank is doing in order to achieve its goal, does not change at all. So the correlations lead to misleading causal paths diagrams. So to summarize, the goals of the central bank remain invariant. They are always trying to achieve that the real interest rate should be 0, but the actions change according to many different possible things. It's like the expert archer who's trying to hit a target. So he adjusts for the wind conditions. He adjusted the direction which he shoots, the velocity with which he shoots. But all of this change is the change in the action, but there is no change in the goal. And so here we can imagine a third situation where the central bank wants to offset the future interest rate, because it realizes that when you set the interest rate, it's actually going to be operative in the next month, not in the past month. So what it needs to do is to anticipate what the inflation is going to be in the next month, and suppose that it can do so accurately. They have very accurate forecasting models. Then it will start setting current interest equal to inflation in the future, and now the path diagram will show that current nominal interest cause inflation in the future, and this is radically different from the truth. The truth about causality is that inflation is exogenous, and the central bank is trying to set nominal interest to make real interest in 0. But the correlation structure will show that the central bank actually drives inflation. The decisions of the central bank are causing inflation. So the correlation structure shows a picture which is dramatically different from the underlying causal structure. Another important aspect of this is that we cannot find out the effects of real interest rates from this data because the central bank is actually trying to hold them to zero. Now, actually, in the data, the real interest rate will fluctuate because it's the random shock that will determine. But this fluctuation will have nothing to do with the domestic variables. So if you do a data analysis, you will find that the real interest rate has no impact on domestic economic variables. And this is an important insight that observing the fluctuations of one variable together with the other variables has nothing to do with what happens when you set that variable according to a goal. These two are entirely different things. So if the central bank governor like Volcker announces that we will set a high interest rate and hold it high until inflation becomes low, then people will change their actions because they know not only that not that the high interest rate has suddenly become high but will go back down because of random fluctuation, but they know that it has been set according to policy and this will stay high in the future, different from past patterns. So they will now react differently. And the literature on this shows that people will think about how credible this announcement is. Can they believe the central bank in terms of will it hold and maintain, or will it change them when a recession occurs? So both the future goals of the planner and also his credibility determines the current behavior. And so the responses from setting real interest rate according to a policy will be very different from responses to random fluctuations in real interest rate. We can provide another example of how correlations can be very misleading about the nature of the causal structure. Suppose a very simple model in which inflation adversely affects growth, and in fact, let's suppose that the higher the inflation, that the expected growth or the economic growth is just minus the inflation. If you have plus 10% inflation, then you have minus 10% growth. Of course, this is not very plausible, but it explains the concept very clearly. In this case, since the central bank wants to achieve nominal interest rate equal to growth, it wants to achieve the real interest rate equal to growth, all it has to do is to set the nominal interest to zero, because the inflation will automatically be equal to the growth rate. And so this will lead to the conclusion that the nominal interest rate has no effect on the real interest rate in this economy. And the three variables, real interest rate, economic growth, and inflation, will be perfectly correlated. And by changing the timing structure a little bit, you can get any type of causal pattern between these three as you like. So none of these correlations between real interest rate, economic growth, and inflation are correct, but the data can generate any pattern by making slight changes in the way that things are observed and set. So again, this comes to the same conclusion, that the correlation structure does not reveal the underlying causal structure. So ultimately, what do we learn from this? We have introduced actually a new concept of causality. Causality has always been treated as action to the observed outcome, but actually we are suggesting that the true causal relationship is between the action and the intended goal. The intended goal may or may not be achieved. The observed outcome is not the intended outcome necessarily. The agents in the economy respond to the goals which are hidden and observed, and not the actual observed outcome. There's an interesting children's experiment where if adults try to do something, even if they fail, like you push a button and you try to turn something on, even if the adults fail, the children infer that something might happen if you push the button, and they try to do it. So they're looking at the goals and not at the observed outcomes. On the other hand, if they see a random connection between two events, a button is pushed and something else happens, but the pushing is done accidentally, they don't deduce the connection because there is no goal involved in the picture. So this is an interesting children's experience, which children experiment, which strengthens our idea that causality is really between the action and the intended goal, and not between action and observed consequence. And this makes the causality automatically dependent on deep inner structures. And this is something which philosophers have not explored because they want knowledge which is universal and not subject to human limitations. But they don't realize that that kind of knowledge is impossible. The only kind of knowledge we can have is the one which is within our human capabilities. One of the aphorisms which is often mentioned here is that causality is in the model, not in the data. And this is supported by our analysis. It is in the model that we think about the goals of the planners and how they set the variables. These are not part of the data structures at all. In fact, there are two models that are involved. One is the true model, which is in operation, which is actually describing the relationship between things which happens in the world. And the other is the model used by the policymaker to decide upon the actions to achieve goals. And we must understand both of these models to understand the world.